Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm Anna, and today we've got a fascinating lineup of stories, from new discoveries about Uranus's magnetic field to upcoming space missions and celestial phenomena. Scientists have just revealed a fascinating discovery about Uranus that's forcing us to rethink what we thought we knew about this mysterious ice giant. It turns out that much of our understanding of the planet's magnetic field has been based on observations made during some rather unusual circumstances. Back in 1986, when NASA's Voyager 2 spacecraft conducted its historic flyby of Uranus, it encountered the planet during what we now know was an intense solar wind event. This timing couldn't have been more unfortunate from a scientific perspective, as the solar wind, that stream of charged particles flowing from the sun, had actually compressed Uranus's magnetic field to just 1/5 of its normal size. According to new research published in Nature Astronomy, these conditions only occur about 4% of the time. If Voyager 2 had arrived just a week earlier, we would have seen a completely different picture of Uranus's magnetosphere, the protective magnetic bubble surrounding the planet. This discovery has significant implications for our understanding of Uranus's moons, particularly Titania and Oberon. Previously, scientists thought these moons often orbited outside the planet's protective magnetosphere. Now it appears they typically remain within this magnetic shield, which could make it easier for researchers to detect potential subsurface oceans on these moons. The findings also suggest that Uranus's magnetosphere is actually quite similar to those of our other giant planets, Jupiter, Saturn, and Neptune. This revelation helps paint a more coherent picture of how magnetic fields work in the outer solar system. Scientists are now emphasizing the crucial need for a dedicated mission to Uranus to better understand not only its magnetic field, but also its atmosphere, rings, and fascinating collection of moons. Such a mission would help us fill in the many remaining gaps in our knowledge about this distant ice giant. Next, another mystery moves closer to a solution. In a breakthrough discovery, astronomers have made significant progress in solving one of space's most intriguing mysteries: the origin of fast radio bursts, or FRBs. These incredibly energetic pulses of radio frequency light have been puzzling scientists since their first detection in 2007, but now we're getting closer to understanding their source. New research published in Nature reveals that these cosmic phenomena are more likely to occur in large, active galaxies rather than smaller ones. The study utilized data from the Owens Valley Radio Observatory, where scientists detected and analyzed 70 FRBs, successfully tracking down their host galaxies. What makes this discovery particularly interesting is the connection to magnetars, highly magnetized neutron stars that rank among the most extreme objects in the universe. The research suggests that these powerful cosmic engines are likely responsible for generating these intense radio bursts. The findings also tell us something fascinating about the environments where these events occur. These larger galaxies tend to be rich in heavy elements, which astronomers refer to as metals. This abundance of heavy elements might be crucial for magnetar formation, possibly through complex processes involving binary star systems. This connection to binary stars is particularly intriguing because we know that 84% of all massive stars exist in these paired systems. When these stars merge, they can create even more massive stars with stronger magnetic fields than either of the original stars would have had individually. This research not only helps us understand where FRBs come from, but also provides valuable insights into how magnetars form and evolve. It's another piece of the cosmic puzzle falling into place, helping us better understand the life cycles of stars and the extreme physics at play in our universe. The team plans to continue their search using an even larger array planned for construction in Nevada, which should help us discover even more FRBs and their host galaxies by 2028, potentially revealing even more secrets about these mysterious cosmic phenomena. Get ready for an absolutely packed week of space launches. SpaceX is leading the charge with an impressive lineup of missions. They've already kicked things off with 2 launches on Monday: the KoreaSat 6A communications satellite from Kennedy Space Center, and a Starlink mission carrying 24 satellites just hours later. But that's just the beginning. SpaceX has 3 more Starlink missions planned this week alone, launching from both coasts. From California's Vandenberg base, they're preparing to send up 20 Starlink satellites, including 13 specialized direct-to-cell satellites. Meanwhile, over in Florida, 2 more batches of their next-generation V2 mini satellites are getting ready for launch. The company is also preparing for another major commercial mission, the Optus-X satellite heading to geostationary orbit. This Australian communications satellite launch is scheduled for Sunday from Kennedy Space Center, marking SpaceX's 7th launch attempt of just this week. Over in China, space activities are ramping up as well. They're preparing for 2 significant launches. The first is a mysterious payload heading up on a Long March 4C rocket from their Taiyuan Launch Center. But perhaps more notably, they're getting ready to send the Tianzhou 8 cargo spacecraft to their Tiangong space station. This critical resupply mission will launch on a Long March 7th rocket from Wencheng, delivering essential supplies to the crew currently aboard the station. If all these launches go according to plan, we're looking at potentially 8 successful orbital missions in just 7 days. A remarkable demonstration of how routine space access has become in our modern era. Next up, some new research into a star that's very dear to us. In fascinating new research from the National Center for Atmospheric Research, scientists have discovered that our sun likely has polar vortices, similar to those we see on Earth and other planets in our solar system. But there's a crucial difference. While Earth's vortices are shaped by atmospheric conditions, the sun's are controlled by powerful magnetic fields. These solar vortices appear to form in a tight ring around 55 degrees latitude, comparable to Earth's Arctic Circle. What's particularly interesting is how they behave throughout the sun's cycle. The vortices move toward the poles in a continuously tightening ring, occasionally breaking off smaller vortices as they go. Eventually, they settle into just 2 vortices at the poles before disappearing completely during solar maximum. The strength of the solar cycle appears to directly influence how these vortices form and move. This discovery could be revolutionary for our understanding of solar behavior, but there's a catch. We've never actually observed these vortices directly. All of our current knowledge comes from computer simulations, as we've never sent a mission capable of viewing the sun's poles. This research could have significant practical applications, particularly for space weather forecasting. Understanding these polar vortices and their relationship to the sun's magnetic field might help us better predict solar events that can impact our satellites and power grids here on Earth. The findings are also timely, as they could help guide future solar missions. The research suggests that these vortices should be observable during most parts of the solar cycle, except during solar maximum. This information could be crucial for planning when to launch future polar observation missions to ensure we get the most valuable data possible. In an unexpected twist for space research, master's students at Nijmegen University have made a remarkable prediction about the European Space Agency's upcoming LISA mission. Their models suggest that when this space-based gravitational wave detector launches in the mid-2030s, it might pick up something surprising: gravitational waves from white-dwarf stars that are actually stronger than those from black holes. This finding has caught many astronomers off guard, as the original mission planning hadn't fully accounted for this potential noise from white dwarfs. But what might initially seem like an obstacle could actually turn out to be a fascinating opportunity for new discoveries. What makes this particularly exciting is that it could give us a completely new way to study stellar evolution in distant galaxies. While our current telescopes can only observe white dwarfs within our own Milky Way, LISA's ability to detect gravitational waves could let us listen in on white dwarfs in other galaxies, effectively giving us a new window into the cosmic neighborhood. The research teams have found that while this white dwarf signal might be stronger than expected, it can be filtered out from the data. This means we won't lose any of LISA's ability to detect other fascinating phenomena, and we gain an additional tool for understanding these dense stellar remnants. This discovery really highlights how space research can surprise us. Even before its launch, LISA is already challenging our assumptions and promising to deliver not just what we're looking for, but potentially even more exciting discoveries we hadn't anticipated. It's a perfect example of how sometimes in astronomy, what we initially consider interference can actually lead us to new and valuable insights about our universe. Here's one for lovers of UAPs. In Washington, an important congressional hearing is set for this Wednesday that could shed new light on one of the most intriguing topics in aerospace: the House Committee on Oversight and Accountability will be conducting a hearing titled Unidentified Anomalous Phenomena, Exposing the Truth, marking their second effort to examine secret UAP research programs conducted by the U.S. government. Representatives Nancy Mace and Glenn Grothman are leading this joint hearing, arguing that Americans deserve greater transparency about what the government knows regarding these mysterious phenomena. The hearing will specifically focus on the Department of Defense's classification policies surrounding UAP and explore ways to make this information more accessible to the public. Among the expert witnesses scheduled to testify is Luis-elizondo, a former counterintelligence officer who has made some striking claims about government knowledge of UAPs. The witness panel will also include Tim Gallaudet, a retired Navy Rear Admiral concerned about underwater anomalies, journalist Michael Schellenberger, and Michael Gold, a former NASA Associate Administrator who serves on NASA's independent UAP study team. It's worth noting that while there's growing interest in understanding these phenomena, NASA's recent independent study found no evidence of extraterrestrial origins for UAPs. As NASA Administrator Bill Nelson stated in September, while there's no proof of alien involvement, there's still much more to learn about these mysterious occurrences. The hearing represents another step in Congress's ongoing efforts to increase transparency around this topic, potentially offering new insights into these unexplained phenomena that have captured public attention and raised important questions about national security. Well, that brings us to the end of today's Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space and astronomy. Whether it's mysterious magnetic fields around Uranus, groundbreaking gravitational wave discoveries, or the ongoing quest to understand unexplained phenomena in our skies, there's always something fascinating happening in space science. If you'd like to stay connected with all things space, head over to astronomydaily.io, where you can sign up for our free daily newsletter and keep up with our constantly updating newsfeed. While you're there, you'll find all our sponsor links, our complete archive of past episodes, and you can even leave us a message. And don't forget to join our space community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until next time, keep looking up and stay curious about the cosmos.